So for question 11.47, we're asked to determine the amount of heat required to convert 500 grams of liquid ethanol at 25 degrees into gaseous ethanol at 125 degrees Celsius. And then they give us the formula for methanol and ask us to calculate the heat for each of those steps. And so what we need to look at is we actually need to diagram out what's happening in the process. So the first part of this diagram is we have 500 grams of methanol at 25 degrees Celsius. I need to heat that methanol from 25 degrees up to the boiling point, which is 78.3 degrees Celsius. So I've got liquid ethanol, I'm heating it up to its boiling point, and now that I've reached the boiling point, I go through that phase transition, and then I have a second calculation as well. Now I'm going to take that liquid ethanol that's gone through the phase change into the gas and heat that up to 125 degrees Celsius. So the first transition that I go through is approximately 53.3 degrees C is my change in temperature. And the next transition that I need to go through is approximately 46.7 degrees Celsius. So for the first calculation, I need Q equals NC of the liquid delta T. I need to find the heat for the number of moles times the molar heat capacity times the change in temperature. They've given us molar heat capacities over here, so we're going to have to use how many moles of ethanol we have in the equation. Next, I need to find the energy for the phase change. I need to go from liquid ethanol, to ethanol that's a gas. So that calculation is Q equals the number of moles times the delta H of vaporization. Now that I've gone through that phase change, my last calculation is back to Q equals number of moles times now the specific heat of the gas times the last change in temperature. So three separate calculations that we have to do. So calculation 1, Q equals the number of moles. Well, moles equals, I have 500 grams of ethanol, and ethanol is 46 grams for 1 mole. So I have approximately 10.87 moles of methanol. So the heat from step 1, 10.87 moles. The molar heat capacity of liquid ethanol, because I'm heating up liquid ethanol from 25 degrees to 78 degrees, 113 joules mole degrees Celsius, and that temperature change is 53.3 degrees C. Step 2, well, I still have 10.87 moles, and the heat of vaporization for ethanol is 39.3 kilojoules per mole. That leaves step 3, the heat from that step, I still have the same number of moles, 10.87 moles. Now I want to know the heat capacity for ethanol in the vapor phase, and that is 420 joules per mole times degrees Celsius. And the last temperature change, now that I've gone through the phase transition, I take it from 78 degrees to 125 degrees. My last temperature change is 46.7 degrees. So multiply all three of those, work through all three of those, and I get approximately 65,468 joules for step 1. I get approximately 427.19 kilojoules for step 2, and then step 3 I multiply through there and I get approximately 213,204 joules. So if we take a quick look at the units, all the units of the answers we're given are in kilojoules, so I need to convert joules to kilojoules. And so I can do that, by multiplying by, there are 1,000 joules in 1 kilojoule. And taking a look at units, right, joules cancel out, and I'm left with kilojoules. So from step 1, 2, and 3, we want to add up, right, the heat from step 1, 2, and 3. So those values come up to be approximately, let's see, divide that by 1,000, 65.47 kilojoules from step 1. Step 2 is 427.19 kilojoules for Q2, and Q3 is approximately 213.2 kilojoules for Q3. Add all three of those together, and I get approximately 705 kilojoules. So originally, 705.9 kilojoules. Originally, I thought I made a mistake and dropped a number somewhere, but I checked my calculation twice. I get the same number twice, so I'm going to go with step C, 707 kilojoules. That's the closest answer. I've checked all my numbers twice. I checked the numbers they gave me, and putting them into the calculation, I get 705.9 kilojoules. So the important thing is understanding when you're going through three different processes. We're taking liquid ethanol at 25 degrees, and we're heating it up to its boiling point. That's my first step. Then I need to take that liquid ethanol at its boiling point and turn it into ethanol vapor. After I've gone through the second step, right, then I've got ethanol in the vapor phase at 78.3 degrees. I need to heat it up all the way to 125 degrees. So three separate calculations, right, where the first one is just heating up a liquid. The second one is a phase change, and then the third one is heating up the gas now. So that's why I had to use the different heat capacities, the separate heat capacities for step 1 and step 3. Step 1, the heat capacity was for the liquid. Step 3, the heat capacity was for the gas. And the last important issue here, they gave us those heat capacities as molar amounts, so as energy per mole per degree Celsius, which means I can't just use the mass of ethanol. I need to convert the mass of ethanol into moles for these calculations.